Good morning to you, everyone. I hope this will find you in good health. So, learners of Senior to North, I greet you in the name of Jesus Christ. This is Teacher Bialgava, and I intend to take you through some simultaneous equations. So, previously in class, we were talking about simultaneous equations, and then remember, I told you of a scenario about simultaneous equations. We said if you, for example, were found eating while walking, we would say you are eating and walking simultaneously. So you're doing two things at a go. So likewise here, under simultaneous equations, we solve two equations. As you can see, these are two equations, and we are solving them at a go or at the same time, and we say we are solving simultaneous equations. Now, one of the methods we talked about is substitution method. I remember giving a few examples, one or two, about them, and I intend to give more examples in this session. So basically, these examples are about substitution method. We also talked about other methods like elimination method. They will come maybe in the next sessions. So we have, given a pair of equations, you can solve the pair of equations using substitution method. And so example 1, you can see, is solve the following pair of equations, and is 3x minus 2y equals 0 and 2x plus y equals 7. Now, when you look at the procedure, I gave out a few procedures such that we can follow carefully to be able to understand this. Now, you can say procedure 1 is label the equations so that the work is made clear. Now, we talked about this. Said you can label the equations. Equation, you can see the first equation, we said equation 1. It is somewhere here, equation 1. Then the second equation, I've labeled it equation 2. So this one is bracket, this is 1 and this is 2. So that we know that the first equation has been given the name equation 1. The second equation has been given the name 2. Then procedure 2 is identify the easier equation and make one of the variables in the equation the subject of the formula. So when you look at these two, we can easily identify that equation 2 is a bit easier than equation 1. Now we have earmarked equation 2 as an easier equation. Now say make one of the variables in the equation the subject of the formula. When I talk of variables, you should be able to understand that it is the unknown in the equation. In this equation 2, you can see x and y are unknown. So we make one of the variables the subject of the formula. You can see from x and y, it is easier to make y the subject of the formula. When I talk of subject of the formula, we previously have looked at this, and it should be easier for you. So we make y the subject of the formula. Now, if you look at equation 3, you can see that I've made y, or y has been made the subject of the formula, and therefore it becomes y equals 7 minus 2x. If you read here, say identify the equation, the easier equation, and make one of the variables in the equation the subject of the formula. In this, let us take equation 2 because it looks simpler. We can thus make y the subject of the formula. So y in equation 2, y has been made the subject of the formula. And how do we make y the subject of the formula? We make it by taking 2x this side, such that it crosses equal signs. You can see here, when it crosses equal signs, it becomes negative 2x, and therefore y becomes 7 minus 2x. So now y is equal to 7 minus 2x, and we label that equation 3. Why? Because now we have 3 equations. We have the first equation, we have the second equation, and we now have the third equation. Now, there is a statement there, it's a guiding statement. Say, when y is made the subject of the formula, we obtain the third equation. Remember, we are following step by step from from unknown to known. Because we have the first equation, we have the second equation, we have identified from these two equations, the simpler one is equation 2. We have made y the subject of the formula, because from equation 2, it is easier to make y the subject of the formula. And therefore now y has become 7 minus 2x. There's another guiding statement here, and it is, we can now substitute equation 3 into equation 1. Remember, our previous equation 3, or our equation 3 is now y equals 7 minus 2x. So we are saying we can substitute equation 3 into equation 1. Remember, our equation 1 is there. So if you take note, look here, take note, we cannot or should not substitute equation 3 into equation 1, because we shall go back to the previous equation if we do so. I remember in one of the sessions we had in class, I showed you that in case you made a mistake and got equation 3 and substituted it into equation 2, you will go back to the previous equation, which is 2. That means you will not have done anything. So what do? You have to take note of the fact that the third equation will be substituted into equation 1. And I've made it clear here in this statement, saying, take note, we cannot or should not substitute equation 3 into equation 1. Should be 1, equation 1. Sorry for that mistake. Should be equation 1. No, equation 2. Sorry about that. Equation 2. Because when we put it in equation 2, we shall go back to the previous equation and we shall not have done anything. So take note, it must be equated or substituted into equation 1. And here it is. So after substituting it in equation 1, remember we are taking now equation 3 into equation 1. And so equation 1 is becoming 3x minus, it is supposed to be minus 2y, but where there is y, we are substituting there the value of y. You can see it here. When you go to equation 3 is that y equals 7 minus 2x. And so if we have 7 minus 2 here, 7 minus 2x here, means that we have substituted the value of y into equation 1. We can open the brackets. Please take note of the brackets. You can see this is negative 2. Here is negative 2. If my camera is clear enough to see that, it is equation 2. It is negative 2. When it enters the bracket, you can see it is becoming a negative 14. A negative 14. But this is negative and this is negative also. So when negative 2 enters in here, you can see it is becoming negative 2 times negative 2, which becomes a positive. Please take note of how we open those brackets. Okay? Most of the learners fail from here. So it is becoming negative 14 because of the negative 2. And it is becoming a positive because of the negative. That's why we have a positive 4 here. Take note of that bracket kindly. And from there, we can collect the like terms, because now we want to find the value of x. If you look at that equation, this equation here, you can see that the only variable now we have, or the only unknown that we have now, is x. And so we can now collect like terms. When we collect like terms, we can have the x's on one side and the constant on one side, and therefore we get the value of x. I took a note here, that take note, when negative 14 crosses equal signs around here, it becomes a positive, not a negative. Kindly take note of that. It becomes a positive. That's why from negative 14, it is becoming a positive 14. And when we divide this out by 7, x will be 2. So when now x is 2, remember we want to solve both x and y, because in the simultaneous equations, we have two unknowns. So now we have solved for x. Solving for x now, we need to find the value of y. But if you will previously remember our equation 3, if my camera is clear enough here, if you remember equation 3 that we made, it is somewhere here. We had that y is equal to 7 minus 2x. 7 minus 2x. But our x now, x is 2. That means we shall substitute 2 into equation 3. And when we substitute there, it becomes 7 minus 4. And so y will be 3. And we thus shall have solved for the value of x and the value of y. So that is how we can solve simultaneous equations or a pair of equations using substitution method. So I was kind enough to look at another example because I presumed that probably one example may not be enough for us to understand better. If my camera will behave like it has done before. Example 2. I intend to look at only 2 examples because I want to give an exercise and I will be awaiting for your solutions. Be waiting for your solutions. I think it is clear here. Example 2. Example 2 we have. Let's check and see for my camera to behave. Yeah, it is 2x plus 5. 2x plus y equals 5. And then x plus 3y equals 5. There are 2 equations. Remember, when you're solving simultaneous equations, those equations first of all have to be 2. And remember, there are some of you, I remember one of you asked me about the teacher, how do you identify that the 2 equations are simultaneous, and therefore you are supposed to to use the methods of solving simultaneous equations to answer the question. And remember, I told you that we identify a simultaneous equations if first of all they are a pair. They are 2. At this level, our level, we shall only solve 2. So we identify, are they 2? Yes. In the 2 of them, or in the 2 equations, are the variables common? When I talk of variables, learners, I mean the unknowns. In this case, the unknowns are x and y. You can see in equation 1, the unknown is x and y. Still, in equation 2, we have the same unknowns, is x and y. And therefore, from this, you can conclude that, oh yes, these are simultaneous equations. And so if I must attempt such a problem, I need to have knowledge of solving for simultaneous equations. Now, when you look at this example 2, remember we are using substitution method to solve these equations. So first of all, we said identify the equations by naming them. So we have named equation 1 and then equation 2, just systematically the way they are. The first one, call it equation 1. Second one, call it equation 2. Don't start with 2 and then 1. That would be ridiculous. But we start equation 1 and then equation 2. So I made this session a little bit talking. You can see from equation 2. From equation 2. Where is equation 2? This one here. From equation 2, I have made x the subject of the formula. I have made x the subject of the formula. Let me put it there maybe for that to remember. We have made x the subject of the formula. So before we looked at simultaneous equations, remember we are looking at making subject of the formula. And so I presume this should be simple for you. We have only moved 3y this side because we intended to make x the subject of the formula. So now you can see x here has now become 5 minus 3y because this y crossed the equal signs and therefore became a negative. I put it in brackets here. We have made x the subject of the formula. Now, after making subject x the subject of the formula, we now have equation 3. Because there are now 3 equations. You have the first one, the second one, and the third. Now, according to the procedure that we have discussed in the first example, we say we are substituting equation 3 into equation 1. You can see here equation 1. Please take note, we cannot substitute equation 3 into equation 2 because we shall go back to this equation here. Where is it? The second one here. And we shall not have done anything. So we take note of that, members of Senior 2 North. We are substituting equation 3 into equation 1. And when you substitute equation 3 into equation 1, somewhere here, you can see equation 1 is this, where there is x, we are substituting there 5 minus 3y, because our x now has become 5 minus 3y, which is this one here. So when you substitute now, you can see that our equation is having only one variable, which is y. Only one variable, which is y. Okay, which is the variable now here has become only y. But before we have the variable, you can see that we need to open up this bracket. We need to open up this bracket. And members, like I said in the first example, learners usually fail around here, around this step where they are supposed to open the bracket, opening up the bracket. But I have confidence that for us we cannot fail because we are very good learners. Now, when you look at this, 2 is entering the bracket, and when it enters the bracket, becomes 2 times 5, which becomes 10. Okay, then take note of this negative here. Now, when the 2 enters, it enters the bracket and becomes 2 times negative 3, which becomes negative 6y. If this had been a positive, we would have a positive here, but it's a negative, so it becomes 2 times negative 3, which becomes negative 6y, then plus this y here, this one here, which is this, and equals 5. Now, you have to collect like terms. We have negative 6 plus 5, negative 6y plus y, it is negative 5y. Okay, negative 5y, because negative 6y plus y is negative 5. Now we collect like terms. I gave a statement here that collecting like terms gives, because we have to put the y's alone and the constants alone. So this 5 was brought to this side, and when it crossed equal signs, it became a negative. You can clearly see this if my camera is still behaving. You can see it went across the equal sign, became a negative, and when this one here, the negative 5y, crosses the equal signs, it became a positive 5y. You can see it here. Now, we therefore have 10 minus 5, which becomes 5. Then the 5y, we have to divide by 5 both sides, and our y becomes 1. So when y is 1 here, because we have divided 5 by 5, y becomes 1. We have to find the value of x. But from equation 3, if you will remember, equation 3, x equals 5 minus 3y. Since we have the value of y as 1, we can substitute here to find the value of x. And therefore, our x becomes 5 minus 3 times 1, because y is 1 and x is going to be 2. And so we shall conclude that x equals 2 and y equals 1. And we shall have solved the simultaneous equation. Thank you for listening to me. I hope you have learned a thing or two from this. I'm going to organize an exercise that I'm going to send shortly after this. And you will attempt it and let me look at the solutions you have made via my platforms or via the platforms that will have been created for you. But meanwhile, first take a look at those and see or make sure that you comprehend what we have talked about. You can let me know of the feedback. I'm going to be online. We can share with me where you have seen where you have had some difficulties. I will be there to help. Thank you very much, and see you.